Okay, hi guys. So we'll be starting on from where we left in the previous lecture, which is we were seeing the methods to remove the hardness of water, permanent hardness of water specifically. So let's see this method. We have anionic exchange or anionic resin. So suppose we have R dash OH. Okay, so this is the anionic resin. These both are same basically. Just either you can use this one or this one. So this actually dissociates into R dash plus OH minus. Okay, and this R dash OH reacts with Cl minus to form R dash Cl plus OH minus. So herein the anionic exchange takes place, wherein OH minus actually gets replaced with Cl minus. We can also have something like SO4 2 minus getting R dash 2 SO4 plus 2 OH minus. Okay, so this is one more method. So next let's discuss the degree of hardness. Okay, so in degree of hardness, the degree of hardness of water is measured in terms of a substance X in parts per million or ppm, so which is hardness of water in terms of substance X. Substance X can be either magnesium bicarbonate or calcium bicarbonate or calcium chloride, magnesium sulfate. So we are writing general substance X in ppm would be, ppm is parts per million. We have already discussed about it in some previous lectures. So mass of substance X divided by mass of water into 10 to the power into 10 to the power 6. Okay, where X can be calcium sulfate, calcium chloride, magnesium sulfate. Okay, so if the by default we use X as calcium carbonate, so if not, it is not explicitly written in terms of any of this, and if you're directly told that the hardness degree of hardness of water is, let's say, 5 ppm, then it is with respect to calcium carbonate. So that's why I'm writing it is by default. If nothing is said, then you have to use X as CaCO3. Okay, so in water, let's talk about the N factor. So in water, N factor of CaCO3, MgCl2, CaCl2, MgSO4, magnesium hydroxide, bicarbonate, all have their N factor as 2. Okay, hence their equivalent weight would be nothing but E by 2. Equivalent weight would be M by 2. Okay, for example, equivalent weight of, let's say, CaCO3 would be 100 is the molar mass of CaCO3 divided by 2, which is the N factor, is 50. Okay, and in water, please remember the format like 1 gram equivalent of CaCO3 would be equals to 1 gram equivalent of MgCl2, which should be equal to 1 gram equivalent of CaSO4, which would be equal to 1 gram equivalent of CaCl2. Okay, Hence we can say that and what's gram equivalent? Gram equivalent is nothing but the equivalent mass of the any compound. Then that means that in water, gram equivalent of CaCO3 or equivalent mass of CO3 would be 100 by 2. CaCO3 would be equal to 95 by 2 grams of MgCl2, which would be equal to 111, which is the molar mass of CaSO4 divided by 2 gram of CaCl2. I beg your pardon, this is the mass of CaCl2, not CaSO4. Would be equal to 120 by 2 gram of MgSO4, which in turn would be equal to 136 by 2 grams of CaSO4. Okay, so let's do a quick question on the same. So suppose a 5-liter river water, 5-liter river water, we collected the sample from any river, contains 190 milligram MgCl2, 55.5 grams CaCl2. This is mg, not grams. Grams would be too much. MgCaCl2, 30 mg of MgCl2 and 68 grams CaSO4. So you have to calculate the hardness of water in ppm. So calculate hardness of water in ppm. So again, when nothing is specified, you have to calculate the hardness of water with respect to CaCO3, which is understood. So just using the format above, so please remember this form, which is very important for handling questions pertaining to likes of this question. So we have 190 mg of MgCl2, which would be equal to 200 grams of CaCO3. Okay, next we have 55.5 mg of, this is not grams, this is mg rather, 55.5 grams of CaCl2, which would be equal to 50 grams of CaCO3. So this is gram equivalent in terms of degrees of hardness. In terms of degrees of hardness, I think I forgot to write it down. In terms of degrees of hardness of water. Okay, when you have to calculate that degree of hardness with respect to any term, then you can equate the given mass to the mass of any of the substance with respect to whom you have to calculate the degree of hardness. So in this case, you have to calculate the degree of hardness of all these substances with respect to CaCO3. So you can just compare the mass of this compound with respect to the compound which has to be used for calculating the degree of hardness. In this case, this is CaCO3. So MgCl2 is done, CaCl2 is done. Then 30 mg of MgCl2. 30 mg of MgCl2 would be nothing but, MgCl2 is done. I think this is MgSO4. There was some mistake in writing the question. MgSO4 here. Yeah. So 30 gram of MgSO4 would be nothing but just divided by 4, which is 25 grams of CaCO3, plus 68 grams of CaSO4 would be just divided by 2, 50 grams of SCaCO3. This is not grams, this is mg. Mg. Here also this is mg. Okay, so total mg of CaCO3 used would be 325 mg of CaCO3. So this is the hardness of water of all the different substances in terms of CaCO3. So hardness of water would be nothing but 325 into 10 raised to power minus 3. This is in terms of grams, divided by 5 liter, which would be nothing but this number of grams multiplied by 10 raised to power 6, which is 65 ppm. Okay, so with this we come to the end of this lecture. From the new lecture we'll be starting off with a new chapter, which is chemical equilibrium. So till then, good luck and goodbye.